All right, this is the online participation quiz, Chapter 4A. Chapter 4 is in two parts, and so this is the first part. True or false, an object moves with constant speed, the net force equals 0. So if an object moves with constant speed, that means that A equals 0. And since we know that their F is equal to ma, that if A is equal to 0, that means that the net force is 0. So that statement is A, true. This figure shows an elevator accelerating downward at 2 meters per second squared. 10 kilogram mass hangs by a rope inside the elevator. What is the tension in the rope? So look at this. I have several forces applied. I have a force in this direction, and I have a force in this direction. This is the weight of the object. This is the tension in the rope. And from Newton's second law, I can say that the sum of the forces equals m times a. That is Ft minus Fw equals mass times acceleration. Ft is what I'm looking for. The weight is going to be the mass times 9.8, so that's 10 kilograms, 9.8. And the mass again is 10 kilograms times the acceleration, which is negative 2 meters per second squared. All right, so that's 98 minus 20, keeping proper sig figs, is 80 newtons. So the answer is C. True or false, it is possible to have motion without a force. Of course, this is like the first one. If my velocity is constant, that means that my acceleration is 0. If I have 0 acceleration, I have 0 force, so that is a true statement. If an object isn't moving, no force acts on it. Let's see, if an object isn't moving, so if an object is stationary, that means that no force acts on it. That's not true. I can have a stationary object, say just a box sitting here. I have the weight of the object, and then I can also have what we call a normal force acting upwards. So if an object is stationary, no force acts on it, that is a false statement. All right, a book is lying at rest on a table. The book will remain there at rest because there is no net force on the book, so causing no acceleration, no net force on the book. A hockey puck slides on ice at constant velocity. What is the net force? Well, if I'm moving at constant... I don't know what that is. If I have a constant velocity, that means that A is equal to 0, which means that the net force is 0. So the net force is E, 0. You put your book on the bus seat next to you. When the bus stops suddenly, the book slides forward off the seat. Why? Well, imagine this is your seat on the bus, and then you have a book lying on the seat. As it's moving along at constant velocity, if A is equal to 0, there is no net force. So the sum of the forces equals 0. Now, when the bus stops, this book is going to continue moving in a forward motion until a force acts upon it. So if no force acts upon it, it's just going to slide right off the seat. So it slid off the seat because no net force acted on it. Now, often there is a net force that acts on it that causes it to stay on the seat, and that, of course, is going to be a force due to friction, which we'll talk about in the next section quantitatively. So there would be a net force that acts upon it if it stayed on the seat, causing it to come to rest. You kick a smooth, flat stone out on a frozen pond. The stone slides, slows down, and eventually stops. You conclude that, which of these? That if it's slowing down, it's decelerating, then it has a net force acting upon it. It has to. If A is not equal to 0, then I know that I have a net force. Consider a cart on a horizontal frictionless table. Once the cart has been given a push and release, what will happen to the cart? If it's a frictionless table, that means there are no net forces acting on it. Once it is in motion, it will continue in motion forever. So it will continue with constant velocity until a net force acts upon it. We decided that the cart continues with constant velocity. What would you have done in order to have the cart continue with constant acceleration? In order to have it accelerate continuously, you have to push the cart continuously. You have to provide a force. Very large truck sits on a frozen lake. Assume there's no friction, so there's no friction at all. And a fly suddenly smashes against the front window. What will happen to the truck? So I have this truck, and then I have this little fly, and he comes and slams into the window. That's going to cause the truck, it's going to exert a force on the truck, causing the truck to accelerate backwards. So the answer is C for that one. From rest, we step on the gas of our Ferrari, providing a force F for 4 seconds, speeding up to a final speed V. If the applied force were only half F, how long would it take to reach the same final speed? Well, we know that V is equal to V naught plus AT. Right? And I also know that F equals M times A. Now, if I apply half the force, that means I get half the acceleration. So if I have half the acceleration, I'm going to need twice the time in order to get to the same final velocity. So the answer is twice the time. It was 4 seconds, so it's going to be 8 seconds. Force F acts on a mass m for a time interval t. The final speed v. If the same force acts on the same time on a different mass 2m, what would be the final speed of the bigger mass? So again, I go back to these same equations. If I double my mass, keeping the same force, that's going to give me 1/2 the acceleration. It's because I have the same force. If I make my mass bigger, then it's going to accelerate at a slower rate. So if I have half the acceleration, in the same time, I will have half the speed. So it's going to be d. If t remains constant, that means I'm going to have a half over here. What can you say about the force of gravity acting on a stone and a feather? This is like the video we watched with the 2 balls. The force of gravity is much larger on the stone simply because it's heavier. So the force of gravity is greater on the stone. What can you say about the acceleration? Well, the acceleration, as we've already talked about, is equal on both always, equal on the stone and the feather. But it's because the stone has more mass or inertia that it experiences a greater gravitational force. A block of mass m rests on the floor of an elevator being moved upward at constant speed. What is the relationship between the force due to gravity and the normal force on the block? All right, well, I'm going to return to our Newton's second law. Better pen here. I have this is my normal force, and then this is my force weight. I know from Newton's second law that the sum of the forces equals ma. In this case, the acceleration is 0 because it's a constant speed, so this is 0. So I have Fn minus Fw equals 0 for Fn, then the normal force is equal to the weight. So that's going to be B. All right, the same situation, but what if it's accelerating upward? Well, let's say the normal force, N, minus the weight equals ma. In this case, the normal force will equal the weight plus the mass times acceleration. So you see that the normal force then is greater than mg. This is like you're going up in an elevator and you feel that sort of pull down on you. That's because the normal force is greater because you're accelerating upward.